video session we have saw introduction of complex numbers in two stages. Two part of introduction we have saw. After that we have derived exercise 2.1 all the 6 sums using the powers I power which can be divided by 4, and we solve and we derive the sum. If we are going to retry once again, anything power 0 is 1, I power 1 is I square is minus 1, I cube is minus I power 4 is 1. This is a cyclic process. Once our I power 8 is 1, I power 12 is 1, I power 16 is 1. The stages will move as a cyclic process. So next we going towards the introduction part of exercise 2.2. In exercise 2.2, first we going to see some introduction areas, then only we going to enter inside a sum. Totally the first sum contains 6 subdivisions, second sum contains 2 subdivisions, and third sum, that is exercise 2.2 is over. So we first will move towards the introduction part in exercise 2.2. For each and every exercise I am going to give some introduction which is very helpful to derive the sums. So we will move towards introduction part. What is the first introduction is nothing but if there is natural numbers we will indicate it as n. If it is whole numbers we will indicate as w. If it is integers we will indicate as z. If it is rational numbers we will indicate as q. Irrational numbers we will indicate as q dash. Real numbers we indicate as r. So how the complex numbers will be indicated? Nothing but c, that's all. C is nothing but complex numbers. This is the first indication of how to introduce the complex number is nothing but C. N is natural numbers, W is whole numbers, Z is integers, Q is rational, Q dash will be irrational, R is real numbers, and C is nothing but complex number. This complex number will be indicated as C. C is the complex numbers. Next, this is the first one I need to say you. Second one. You know this as this equation I given in the introduction part itself in the video itself, nothing but x square plus 1 is equal to 0. That is x square is equal to minus 1. X is equal to square comes this side becomes square root of minus 1. Once the square root comes we need to put plus or minus. X is equal plus or minus square root of minus 1 is nothing but I. Square root of minus 1 is nothing but I. X is equal to plus or minus I. This is one way of thinking. The another way of thinking, for what value of x the equation becomes 0. This is the another value of thinking we can think. For what value of 0? If I am going to put minus 1 the whole square is nothing but 1. 1 plus 1 is equal to 2, which can't become 0. The only way is square root of minus 1. If I am going to put square root of minus 1 the whole square plus 1 is equal to 0. If I go in place of x, if I am going to apply the square root of minus 1, then only square root and square can be cancelled, so it becomes minus 1. Minus 1 plus 1 is equal to 0. So in place of x I need to apply square root of minus 1. This square root of minus 1 is nothing but plus or minus I. In this way also we can think and we can derive the answer. This is the second iteration way I need to tell you, say you. This is a parabola. This parabola does not cut the x-axis. It will touches the y-axis only, but not cuts the x-axis. Any equation which cuts the x-axis, any parabola, any parabolic equation or any quadratic equation which cuts the x-axis as a solution. This equation does not cut the x-axis, therefore it does not has the solution. So the third one, the general form. For example, for matrix representation, if you want to represent the matrix, we will represent caps A, caps B, caps C, caps I, and O. We will represent A, B, C, I, and O. For example, identity matrix, 0 matrix, A matrix, B matrix, C matrix. If we need to represent a vector, we can represent A vector, B vector, C vector, N vector. We can represent a vector, OP vector. If we need to represent a vector, we will represent like this. If we need to represent a complex, if we represent a complex number, we are going to represent z, small z. Z is equal to x plus iy. This is our representation of a complex number. We can represent a complex number with small z. Most of the students will apply z like this, so no problem. You can put z like this also, no problem. Because I'm not putting z like this, because 2 also some students put like this. 2 and z I can't able to differentiate. So only after putting z, I am crossing one line. Suppose z is equal to x plus iy, z is equal to x plus iy. So this is the complex number. Complex number can be represented in this way. Z is equal to x plus iy. For example, we can represent z1 is equal to x1 plus iy1. z2 is equal to x2 plus iy2. So first formally we take z is equal to x plus iy. From this itself we know this is real part, real part. This is I near, this is imaginary part, we can say this is a real imaginary number or complex number, no problem, but this is z is equal to x plus iy, this is real part, this is imaginary part. So how I can find real? RE stands for real part of z, real part of z. What is a real part of z? Real part of z is nothing but x is equal to x. Real part of z is nothing but x. Next, im, imaginary part of z. Imaginary part of z is nothing but y. Imaginary part of z is nothing but y. Real part of z is nothing but x, and imaginary part of z is y. This was introduced by Gauss. This representation of a complex number was introduced by Gauss. Gauss, the mathematician, introduced the representation of a complex number. I had told in the previous class itself, this is organ plane. Why it is called organ plane? Listen. So this is nothing but real numbers. This is nothing but imaginary numbers. This is nothing but real numbers. This is imaginary numbers. So this plane we call as organ plane. For example, if this is xy coordinate. This we can say xy coordinate plane. So this is called organ plane. This is called xy axis. This here real and imaginary. In this line only real number is present. Totally fully complex, that is imaginary numbers will be present. In this plane fully imaginary numbers, only on this line only real line will be present. For example, 2. Where is present 2? Here is present 2. 3 is present. Root 2 is present here. All the real numbers will be present here only. Real numbers and rational numbers and irrational numbers. In this line contains natural numbers, whole numbers, integers, rational numbers, irrational numbers. All are contained in this line only. Only the imaginary we call as 1, 2, 3, minus 1, minus 2. This is purely imaginary. It contains only imaginary line. This contains only purely imaginary. This is purely imaginary. This contains only imaginary line. This is called imaginary number. It contains only this imaginary line. This imaginary line contains only imaginary number. For example, 2 is real. 2 is only a real. For example, 3. You can put I also, no problem. In textbook they will not use I. But if you are going to put I also, no problem. You can put 3I, 2I, 1I, no problem. You can use I also, no problem. Otherwise, you defaultly you need to know that this is imaginary line. So it contains a imaginary number only. For example, if I want to plot z1 is equal to 2 plus 3I. 2 is present here. 3 is present here. So I can write 2, 3. Otherwise, I can write as z1. This point is nothing but z1. Otherwise, I can write z1 is equal to 2 plus 3I. Because this is a complex number. The whole fully contains only complex number. Fully contains only complex number. This contains only the complex numbers. That is imaginary numbers. This line only contains real numbers. Full plane contains imaginary numbers, nothing but complex numbers. In this, the main special one is 0. 0 can be a real, 0 can be a imaginary. 0 can be real, 0 can be imaginary. For this, I am going to give one example. For example, before giving that example, I need to tell you one important thing. After that, I will tell you. So, for example, z is equal to x plus iy. Z is equal to x plus iy. For example, z is equal to x plus iy. If this is real, this is imaginary. Real and this is real and this is imaginary. If the real part is going to be 0, there contains only imaginary part. I will say once again. if this real part is going to become 0, 0 means 0 plus iy is nothing but iy, nothing but if real is nothing but x is equal to 0, then which implies z is equal to iy, then we can say it is iy means present only on the imaginary line, so it is purely imaginary. You can say it is an purely imaginary. If z is nothing but iy, it is called purely imaginary. Suppose if imaginary that is y is equal to 0. If imaginary y is equal to 0, then only x will be present. See, z is equal to x. That is which implies z is equal to x. This is real. You don't need to say it is purely real. You don't need to say it is real, that's all. This contains real. So you don't need to say it is purely real. So you can say it is a real. Z is equal to x, it is a real. This is called purely imaginary. Iy, z is equal to iy is if there is no real values, then purely imaginary. If there is no imaginary value, it is real value. Listen, once again saying, for example, I can give few examples also. Z is equal to 4i. Z is equal to 4i. How I can write this 4i? I can write 0 plus 4i. 0 plus 4 is nothing but 0. What is real part? Real part is 0 and imaginary part is nothing but 4. So since real part is 0, we have imaginary part. This is purely imaginary. It is purely imaginary. Suppose if the z is equal to 5. Z is equal to 5. How I can write 5 plus 0i? I can write the 5 plus. This is real. 0 is nothing but imaginary. Since imaginary is 0, we have only real part. We can say it is real. That's all. Since it is real, having only real, it's called real. If it's having only imaginary, it is called purely imaginary. Simply, I can say absence of real, purely imaginary. Absence of imaginary, it is real. That's all. This is the main thing. For example, z is equal to 0. How I can write 0 plus I0? Here real is 0, imaginary is 0. Real is also 0, imaginary is also 0. From this, what you know? This 0, the special character, 0 can, this is special one. 0 belongs to imaginary and 0 belongs to real. No problem. 0 is real, 0 is imaginary. So 0 can be real and 0 can be imaginary. No problem. So from this you need to learn that. This is the correct format. Z is equal to real part of z plus I into imaginary part of z. This is first you need to write real, next you need to write imaginary. At the same time, the complex number should not present the denominator. You need to make only numerator. If it is present denominator, you need to conjugate and you need to bring to the numerator. So this is the main thing you need to learn here. So you know the organ plane. You know this is the organ plane. You know this is organ plane. Why it is called organ plane? Because it contains this is called real numbers and imaginary. Real line and imaginary line. So it is an organ plane. You know how to point also. I teach you how to point also. So it is very easy to point. So now we can move towards the sum. Exercise 2.2. Evaluate the following. If z is equal to 5 minus 2i and w equal to minus 1 plus 3i. First subdivision to find z plus w. Z plus w, or we can find what is the z here? 5 minus 2i plus w minus 1 plus 3i. This is just a algebraic addition only. How we can add in algebraic? X variable will add to x variable, y variable will add to y variable. The same procedure. Real will add to real. Real will goes to real only. Real will move to real. Imaginary will move to imaginary. That's all. The addition. Real will goes to real. Imaginary will move to imaginary. So if you're going to see 5 minus 1, which gives us 4, minus 2i plus 3i plus I. Minus 2i plus 3i is 1i. This 1i I can write as plus I. So this is the first 4 plus, this is the first sum 4 plus I. Very easily we can add this. So second subdivision, z minus iw, z minus iw. First write z, 5 minus 2i minus I w minus 1 plus 3i. Now 5 minus 2i, multiply minus I inside, minus into minus plus, I into 1 is I, minus into plus minus 3, I into y, I square. We know the value of I square. I square value is nothing but minus 1. I square value is nothing but minus 1. So how I can do 5 minus, see this is imaginary, we'll wait for next line, minus 2i plus I minus 3, I square value is minus 1. So 5 minus 2i plus I minus into minus plus 3 into 1 is 3. 3 into 1 is 3. Now you can add real and real. 5 plus 3, 8. Imaginary and imaginary. Minus 2i plus I. Minus 2i plus I, which gives us I minus I. So hereafter you need to learn I into I square. I square value is minus 1. You need to learn this the next time. Next, third subdivision. The third subdivision given for us is easy subdivision only. 2z plus 3w. So 2 into z value is nothing but 5 minus 2i plus 3w minus 1 plus 3i. Just like usual multiplication only. 2 5s are 10 minus 2 2s are 4i plus 3 into minus 1 minus 3. So erase plus and put minus 3. Plus into plus plus 3 3s are 9i. 3 3s are 9i. So real and real. 10 minus 3, 7. Imaginary and imaginary. Minus 4 plus 9, which gives us plus 5i. This is a proper form. Real and imaginary. Next, the fourth subdivision is z into w. Multiplication of two complex numbers, just as same as algebraic one only. 5 minus 2i is multiplied with minus 1 plus 3i. So multiply 5 into minus 1 minus 5. 5 3s are 15i. Minus into minus plus 2. 2i into 1 is 2i into 1 is 2i. I will do once again. Minus into minus plus 2i into 1 is 2i. Minus into plus minus 2 3s are 6. I into y, I square. I square value is minus 1. Now write it properly. Minus 5 plus 15i plus 2i minus into minus plus 7 minus 6 minus into minus plus 6 into 1 is 6 minus 5 plus 6 plus 1 15 plus 2, which gives us 17i. 1 plus 17i. Fifth subdivision, z square plus 2zw plus w square. This is the formula nothing but a square plus 2ab plus b square. This is the formula. A is nothing but z, b is nothing but w. A square plus 2ab plus b square is nothing but a plus b the whole square formula. This very known formula. A plus b, z plus w the whole square. Z plus w the whole square. Now we can add z and w. What is z here? 5 minus 2i plus w. W is nothing but minus 1 plus 3i whole square. Z plus w. So what the answer is going to be? 5 minus 1 is 4. Minus 2i plus 3 is nothing but I. 4 plus I the whole square. Once again we can use the a plus b the whole square formula. A square plus b square plus 2 into a into b. So what is 4 square? 16. What is I square? Minus 1. 2 4s are 8i. 2 4s are 8i. 16 minus 1, 15. 15 plus 8i. What is the formula we use here? A plus b the whole square is equal to a square plus b square plus 2ab. This is the formula we used here. Fifth subdivision is over. Next, sixth subdivision. The sixth subdivision is z plus w the whole square. Now only we saw z plus w the whole square is nothing but 4 plus I the whole square. We know what is 4 plus I the whole square. 15 plus 8i. we can use here itself and we can stop our sum. Next, second sum. So second sum is also very easy sum. Given complex number z is equal to 2 plus 3i represents the complex number in organ diagram. We need to represent these complex numbers. Which are complex numbers? Z, iz, z plus iz. We need to represent the organ diagram. So solution. First write z. What is z answer? Z is nothing but 2 plus 3i. Z is nothing but 2 plus 3i. So we can write in point itself nothing but 2 comma 3. We can represent point 2 comma 3. Next, what is given? iz. So I into what is z value? 2 plus 3i. So writing I into 2 is nothing but 2i plus 3. I into I is I square. 3 into I square. I square value we know. I square is nothing but minus 1. You should learn this. I square is nothing but minus 1. So write it properly. 3 into minus 1 is minus 3. Minus 3 plus 2i. So we can represent the point minus 3 comma 2. Minus 3 comma 2. If you represent a point, it's very easy, no? So only represent a point. The next step, z plus iz. Z plus iz. What is z value? 2 plus 3i. What is iz value? Normally we have found the iz value minus 3 plus 2i. Minus 3 plus 2i. This is z. This is iz value. Z plus iz. Z value is nothing but 2 plus 3i. Iz value is minus 3 plus 2i. So it was very easy, no? So only written like that. You don't need to do once again. I into z, you don't need to do once again. 2 minus 3 minus 1. 3i plus 2i, which gives 5i. We can represent the point minus 1 comma 5. Now we can draw the diagram. So as I told previously, this is real number line, this is imaginary number line, plus real, minus real, plus imaginary, minus imaginary. Even though you're going to put I, no problem. I, 2i, 3i, 4i, 5i, no problem. You can put I also. Otherwise you can simply leave it as it, because we have mentioned this is an imaginary, so no problem. What is the first point? 2 comma 3. 2 is present here, 3 is present here. This point is nothing but 2 comma 3. In spite of writing 2 comma 3, I will going to write as z, because z is nothing but 2 comma 3. Next, minus 3 comma 2. This is minus 3, this is 2. In spite of writing minus 3 comma 2, I am going to write iz. I am going to write iz. Next point, last point, minus 1 comma 5. Minus 1 is present here, 5 is present here. This is z plus iz. Z plus iz. Now we need to join these points. We need to join these points. So after joining the points, we have formed a triangle. This is nothing but right angle triangle. If you're going to see, if you're going to check, this is nothing but a right angle triangle. So the last conclusion we need to write z comma iz comma z plus iz forms a right angled triangle. So now we go towards the second subdivision. Z is equal to 2 plus 3i, second subdivision, z minus iz, z minus iz. So how are we going to form solution? Z we know z value 2 plus 3i. The point we can form is nothing but 2 comma 3. Next, minus iz, minus of I, z value is 2 plus 3i. So multiply minus I into 2 is minus 2i, minus into plus minus 3, I into y, I square value is minus 1. You know I square value is minus 1. So write it properly, minus into minus plus into 3 minus 2i, 3 minus 2i. First real, then only imaginary. The last z minus iz is equal to, what is z value? 2 plus 3i minus minus. What is iz value? Otherwise you can simply write minus iz value. What is minus iz value? 3 minus 2i. So write 3 minus 2i. If you want, z value is 2 plus 3i minus iz value. Minus iz value is 3 minus 2i. So write 2 plus 3, 5. 3i minus 2i, which gives us plus i. So for this you can write this point 3 comma minus 2. You can write this point 5 comma 1. 3 comma minus 2 and 5 comma 1. Now you can draw the organ plane. Organ plane is very easy, no? So now you need to draw the organ plane. The organ plane is nothing but the real and imaginary, that's all. So this is, you need to draw using scale only. This is plus real, this one is minus real, plus imaginary, and this one is minus imaginary. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, minus 1, minus 2, minus 3, minus 4 and minus 5. The first point is 2 comma 3. 2 is present here, 3 is present. 2 comma 3 is nothing but z. 2 comma 3 is z. Next, minus iz, point is 3 comma minus 2. 3 is present here, minus 2 is present here. This is minus iz. The last value is 5 comma 1. 5 is present here, 1 is present here. 5 comma 1 is nothing but z minus iz. Now we need to join these 3 points. First point, second point. Now we are going to join second and third point and first and third point. Therefore, once again triangle is formed. This triangle is nothing but right angle triangle. It's nothing but right angle triangle. So the last conclusion we need to write z comma minus z comma z minus iz forms a right angle triangle. Some students will ask me how it is a right angle triangle. It can be a triangle, no. Isosceles triangle can be a scale. How it can be a right angle triangle? Because I can prove it is a right angle triangle using the previous sum or this sum also. But I will prove in this sum itself why it is a right angle triangle. Right angle triangle is nothing but, what is z value? Z value is nothing but 2 plus 3i. 2 plus 3i. Take modulus. Modulus of z is equal to modulus of 2 plus 3i. According to complex number, while taking the modulus, we need to put a square root. Real square, 2 square. Next, imaginary square, 3 square. You should not put I square. What is a real? 2. What is imaginary? 3. 2 square plus 3 square. Answer is nothing but 13. 2 square is 4. 3 square is 9. 9 plus 4, 13. Next for modulus of minus I is. Modulus of minus nothing but, what is answer? 3 minus 2y. 3 minus 2y. Same. Real square, 3 square plus imaginary minus 2 the whole square. What is the answer is going to be? The same answer, square root of 13. 3 square is 9, 4 square is 2 square is 4, 9 plus 4 is 13. The final is z minus I z. Modulus of z minus I z is equal to modulus of 5 plus I is equal to 5 square plus 1 square. Real is 5, imaginary is 1. 5 square is 25. 25 is nothing but square root of 26. If you are going to check 13 plus 13, 26. You know hypotenuse square is equal to opposite square plus adjacent square. Nothing but hypotenuse square 26 the whole square is equal to square root of 13 square plus square root of 13 square. That's all. So you can finish this and right angle triangle, hypotenuse square. This is hypotenuse, opposite square, adjacent square. So this one forms a right angle triangle. This is not necessary, but show it is a right angle triangle. You can prove this, no problem. Third sum, one of the important sum in exam point of view. Find the values of real numbers of x and y. I need to find the values of x and y. This x and y are real numbers only. If the complex number, this is the first complex number and second complex number are equal. They are told these two complex numbers are equal. They are told these two complex numbers are equal. I need to find the values of x and y. Solution to find x and y given, what is given? The two complex numbers are equal. So I can write 3 minus I into x minus 2 minus I into y plus 2y plus 5 is equal to 2x plus minus 1 plus 2I into y, 3 plus 2y. Now I can multiply 3 into x, which gives us 3x, minus I into x is nothing but ix, 2 into y is 2y, minus a present, so minus 2y, minus into minus plus yi plus 2I plus 5 is equal to 2x, minus 1 into y is minus y, plus into plus plus 2yi, next 3 plus 2I. Let all this quantity comes towards the left hand side, or all this quantity move towards the right hand side, our wish. Better I will bring towards all the things on the left hand side. So 3x minus ix minus 2y plus yi plus 2y plus 5. Let bring this side, becomes minus 2x, this become plus y, become minus 2yi, become minus 3, become minus 2y, final is going to be 0. The main thing, we need to arrange real and imaginary. Arrange real, imaginary. Arrange real and imaginary. So we need to arrange real and imaginary. So arrange real and imaginary. Are we going to arrange real and imaginary parts? Which are real here? See here, 3x is real, minus 2y is a real, 5 is a real, minus 2x and y is also a real, 3 is a real. These are real. Before arranging, I can write 3x minus 2x, which gives us x, minus 2y plus y, minus 2y plus y, which gives us minus y. Check it. 5 minus 3, 5 minus 3, which gives us 2, plus 2. This is real. Next, imaginary. The boxless, there is no box for imaginary. See, in boxless, see, this is I. So I can go and take I outside. After taking I outside, this is become I outside, this become minus x. I outside, this become plus y. I outside, this becomes plus 2. I outside becomes minus 2y. I outside becomes minus 2. That's all, is equal to 0. So this is x minus y plus 2 plus I, arrange it properly, minus x, y minus 2y is minus y, 2 minus 2 both are cancelled, is nothing but you can write as equal to 0. Now the main part now only works here. So this 0 I can write as 0 plus I0, no problem. You know 0 is equal to 0 plus I0, no problem. This 0 is real, this 0 is imaginary. Real part, imaginary part. Now which one is real? This one is real, this one is imaginary. In left hand side the same, this one is real, this one is imaginary. Real and imaginary. This is real, this is real, real and real, now equating real and imaginary, equating real and imaginary, equating real and imaginary. Which one is real in left hand side? X minus y plus 2 equal to 0, this is real. Minus x minus y equal to 0 is imaginary. Real to real, this is real, real. X minus y plus 2 equal to 0, real. Equating imaginary, you should leave the I. Imaginary, minus x minus y equal to 0, imaginary. X minus y minus 2 equal to 0 and minus x, I think so. Minus x minus y, minus x minus y equal to 0. So keep it as equation 1. Before keep it as equation, let minus 2 moves this side, becomes plus 2. No, x minus y is equal to plus 2. Keep it as equation 1. This is keep it as equation 2. Solve 1 and 2. Solve 1 and 2. First write first equation, second write second equation. What is the first equation? X minus y is equal to minus x minus y is equal to 0. Plus x minus x cancel, minus y which gives us minus 2y. This is 2. So bring down minus 2 on right hand side of denominator. 2 divided by minus 2 which gives us minus 1. So y value is minus 1. Y value is, sorry students, while writing the answer, this is plus 2. This is plus 2. While come this way minus 2. This is minus 2. Minus 2. Minus cancel, it becomes plus 1. Okay. While writing the answer, I left out, I written minus. But it is given as plus. X minus y plus 2. So plus 2 come this way becomes minus 2, minus 2. Minus 2 plus 0 gives us minus 2. Minus 2, minus 2. Minus cancel, 2 by 2 is plus 1. Y is 1. So apply y is equal to 1 in equation 2. You can apply in any one equation. Minus x minus y is equal to 0. This is equation 2. So minus x minus y is 1, no, equal to 0. Minus x minus 1 comes there, becomes plus 1. So we need only x value. So multiply by minus, x is equal to minus 1. Therefore the final answer is x is equal to minus 1 and y is equal to plus 1. Within this, we are finishing this exercise 2.2.